whatever we read before, no, these are the definitions, theorems which developed much later to usage of first law. That's how no first law is a first law because the first scientific way of developing the product in the society. After, when they started using this law, no, they needed more definition. That's why they defined more things which we read well before this one, including the zeroth law, as I said. So if I repeat this particular full view, please. If a control mass undergoes a cyclic process, it's very important that whenever I am stating a law, no, I am more comfortable, confident to say for a control mass. If it is a control volume flow entering and leaving, then there are so many clauses, so many equations to be satisfied. That's why very difficult to. So that's why if it is a control mass, no, I don't have to depend upon the conservation of mass at all to make a statement because obviously a constant mass. So that's how if a control mass undergoes a cyclic process, the cyclic integral of heat transfers is proportional to cyclic integral of work transfer. Here I am using the word heat and work because these are actions. Heat means heat transfer, work means work transfer. They occur only when there is a something happening. There is nothing like heat possessed by a body or possessed by a system. So whether I say heat or heat transfer, both mean that it is action. And the mathematically, the cyclic integral of delta Q is identically equal to cyclic integral of work transfers. This is the law of nature because we derived this one logically or technologically, whatever uses, this law based on the conservation of energy. Conservation of energy is a law of nature. You imagine this is most useful way of stating a conservation of energy. Otherwise, what we do, if you recall in your school, how did you prove the conservation of energy? You take a body and try to throw the body. When the body is moving up, you will say that there is initially all kinetic energy, zero potential energy. When it is the middle, half kinetic energy, half potential energy. When it goes up, zero kinetic energy, only potential energy. That's how you account it. A law only for a ball game. What is the use of such a law? The law has to be more for the engineering, more for changing the lifestyle of human. So can be described precisely for a control mass without any confusion. And basis is only experimental because law of nature cannot be proven by any analytics. Okay, and the first law can never be disproved. There can't be. You just can't disprove this one. So that's how. If I go into the engineering consequence of this one, in fact, of first time, all the innovators are put in a right direction. The people were not allowed to do blunders or mistakes at all. They were made to think properly. Okay, what is the thinking properly? Every engineer should think in a practical way or talking that what is impractical. You see the beautiful statement engineering. Any mission which violates the first law is called a perpetual motion of first kind. Anybody who is trying to think about a mission which doesn't follow first law, violating a first law, he must be thinking fantasy. He is not doing a real engineering at all. A company or a society or a government should not spend money on such a innovation. It's a wastage of resources. And many people come to me as a rural inventors. They have sold off all their ancestral properties and their idea is against the first law. It was so tough to tell them, you are stupid, you are wasting your life. I'll give you examples step by step. So that's how it is called a PMM1. What is the PMM1? PMM1 is a control mass which works continuously in a cycle and violating a first law. How violate? There are 4 ways of violating a first law. Let me tell. PMM1 is a control mass continuously working in a cycle forever but generates only work, nothing else. It doesn't take anything from the environment or the surroundings, but it continuously gives works to the surrounding, which is against the law of nature, creating energy from nothing, which is obviously impossible. The second one is which consumes only. Even that is also not possible. You are depleting the energy continuously, which is against the law of nature. A PMM1, anybody who is trying to come up with a concept, I have developed a new idea, it takes nothing and gets work, something wrong with them. Somebody says, no, 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 I have developed an idea. It takes work, millions and millions. You dump it to it, it will take it. Perhaps. No, that is also impractical or a fantasy. Or other way, it is impossible to have a control mass which is working in a cycle continuously. Very important. For a 2 minutes, no, you can have a one which will consume all the heat, do nothing. For a fraction of a second, it will be possible. But that is not the theory. A theory has to work for a millions and millions of years, decades. Those are called the valid theories. Doing for a fraction of a second something is not the theory at all. That's why continuously in a cycle, not for a fraction of a second. A fraction of a second, it works. So you take a car and push the car and you stop it, the car is running. It looks like a car is running on its own without a fuel. For a small fraction second, it is a feel. But you forget that you have given before a fraction of second lot of energy by your muscles that you ignore. All these things are very important to understand. And similarly, it is impossible to have a perpetual motion machine of first kind which works in a cycle and gives heat, gives heat, gives heat. All of us know that even in the sun, which is giving a lot of energy continuously, there is a fusion. Mass is converting into energy continuously. That's why there is a heat. It is not like creating for nothing. Even the sun is not a PMM1, and the sun is consuming some of the reserves available in the nature. That's why the people date, even sun will die after some time. The time is so large that for a common man it looks like a perpetual mission. So at the end of the day, every engineer should think that it is impossible to construct a perpetual motion machine of first kind. If he thinks to do this particular one, he is not an engineer. Any thermodynamics which is worked on this one is not an engineering thermodynamics at all. It is an abstract or a fantasy thermodynamics which is trying to think about it. Because thermodynamically it looks like I can do, but it is not done. I'll give you the fantasy thermodynamics. And the people spend lifetime. I had to work with them to prove them wrong because they had some kind of recommendation from the politicians and the sponsoring agency was under a pressure. They had to, but finally they included me to prove that fellow that he is wrong totally to the politician or the nation at a large. Let me explain you why engineering view of first law is essential. Give me a whiteboard. The first thing which happened is there was a person who said ki I have developed an automobile. Okay, in this automobile there is no engine at all, there is no fuel consumed at all. Then how will it rotate? There will be a windmill which is attached. Okay, so this is rotating. I can connect it through the differential, the wheels, maybe 4 wheels I can connect. Whenever there is a wind, the windmill will rotate and it will rotate the car can move upward, forward. Now, then it will work only when there is a wind, enough wind. No, 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 no. It will not require a wind velocity at all. Without a wind velocity also it can work. Then how? So he says ki first I'll take few people to push this one. So the moment I push, it will attain a velocity v. The moment there is a velocity, the wind will have a equal and opposite velocity v. Because there is a wind velocity, this particular turbine will rotate. Then the car is running. Because there is a turbine rotating the car is running with a velocity. Because the car is running with a velocity v, there is a wind velocity. The people spent lifetime. This particular person, I will not take the name for some of the reasons. What is this one? This is a perpetual motion machine of first kind. It takes nothing from the universe and continuously doing a motive work. So somebody spending a lifetime on this one is wasting everything. So people have to think that it is impossible. Suppose if you want to produce something new, you need to have a fuel tank, you need to have an engine. Continuously you feed the fuel from the nature. And this mass of fuel, by the virtue of the calorific value, will give some amount of heat to the system. So that's how the next important engineering view is always you should have, whenever you are developing a machine, you should make sure that it will satisfy the first law of thermodynamics. What does it mean? Let us say there is a black box which you are inventing. Okay. Whenever you are inventing a block box, you see what is your resource. I have some heat. I'll give you some heat in. Okay. And I want this to produce some amount of work output. Okay. But I'm not sure whether all the heat will be converted or not. There may be some amount of rejection also. Okay. Maybe sometimes for a small while I have to push even. I have to do some work in also, because you see, you don't have any vehicle on the globe which can start without a starting motor. Means initially I am doing the work to pick up. Even that is a work input. I am giving in a mild sense. Suppose if this is there, this entire thing is practically viable if and only if the cyclic integral of work transfers is equal to the cyclic integral of heat transfers. If it is continuously happening, you can have a dot also, because things are changing with the time. Because I'm continuously producing. I'm not interested in producing for a minute. There is an accounting done. Okay. I may have to do 24 hours a day, 365 days a year to lighten the nation. To empower the nation, I need a 24 hours a day, 365 days a year electricity. Can you think? Today is a Sunday, no electricity. Be in the house, don't do anything. Will it be possible? Either Sunday or a Monday, we need electricity for living happily, or we need many other form of resources happily. The heat and work transfer are essential every minute, every second, whether you are sleeping or working, it was required. So this is the first amount of this. So only these things will prevail. But again, there is a confusion. There is no rule, or there is no specific that all the heat which is given without rejecting anything, without any other work, can I convert or not? The first law is not aware. The first law talks about is you need to have a cyclic integral. In the cyclic integral, all heat transfer could be heat addition, all heat transfer could be heat rejection, or a combination of some heat input, some heat rejection. The first law is ignorant to uh, this particular one. It is only talking about the cyclic integral. The moment I have a cyclic integral, now how the people enjoyed this one, you see, the first mission which responsible for all the theory was steam engine. How did they use the steam engine? You think about it. I am constructing. It's very, very important to use an engineering view of first law of thermodynamics, which gives the next step to the entire thing. Now you see, there is a boiler filled with a water, and I'll burn coal, and the calorific value of coal will give the heat into the entire system. So this is the QEEE explicitly happening. Maybe in an ideal condition, mass flow rate of fuel multiplied by calorific value. Now this produces a steam. Through a valve, a controlled amount of steam, I'll send it through a pipeline. Very beginning, the people thought this is only the way you can have it. That is, there is a piston. The piston is connected through connecting rod and the crank radius, or maybe some other mechanism which is immaterial for us. So the slowly the high pressure steam is coming, and below the piston it is very low pressure or atmospheric or whatever I say, and this high pressure steam is pushing. So because of which this is doing a integral PDV. So once the piston comes to the bottommost position, then what I should do? I should do a two-way. Either I change the steam path and introduce from the bottom and remove this particular steam. Okay? Or don't care about this one, you give only once. That is up to you whether you want a very compact or a very broader. Okay, it is up to you, two-way acting, etc. So whatever rejected steam, okay, you can throw it to atmosphere. That is one way of doing, which is ridiculous. Or you can recycle the steam. But to recycle the steam and going into this particular one, which is at a high pressure temperature, so what should you do? You should have a condenser. All the steam goes, and take a water from a river or so and cool the entire thing. Then what will happen? All the steam will condense and you have a water. Now this water you pump it into the boiler. Okay, sorry. Oh, this is below, no? Sorry. You have this one. So I'm drawing a pipeline for the sake of feel. Okay. Now you see this particular one. The most acceptable thing was continuously feed the water into this particular one at high pressure, and you add the heat. So because I'm driving a pump, I have to give some work input. Okay. And use this particular steam to drive a steam engine, and this will produce a huge amount of work output. So much that the people could run the trains, people could run the ships, people could construct big hammers to break the rocks, etc. You imagine the people developed many things to this one. And after this, the waste stream will go through a condenser. This is a condenser, okay, and it will be converted back into water. Then, sorry, you pump this particular one. To pump it, you need to use some work input. So when I see this particular one, draw a boundary, sorry, draw a boundary, okay, all around this particular one, okay, I draw a boundary. Now you see this one. See, if I take a boiler, it is a control volume. Water is entering, steam is leaving. Engine, steam engine, piston cylinder arrangement, there is a steam entering, steam leaving. If I take the condenser, steam is entering, water is leaving. If I take the pump, water is entering, water is leaving. But when I close the everything, which is making a cycle, no mass crosses. And what is crossing? Some amount of heat transfers, some amount of work transfers. So you see this one, whenever I develop a cycle, individual part of the cycles may be control volumes. But when they work and connected together, you see this one, the boiler is connected to the steam engine is connected to the condenser is connected to the pump is connected to the boiler. They are head and tail, head and tail, head and tail connected in such a way that no mass crosses the boundary. It looks like every cycle can be possibly constructed as a control mass, though individual components could be control volumes. So that's how whenever I'm stating a first law, no, I don't have to worry about the control volume at all, because every cycle is possible by having a equivalent control mass. Sometimes no, this control mass assumption could be virtual. What is that virtual? You imagine. Suppose if I'm having a jet engine, aeroplane engine. Now let us say this is a big aeroplane and there is a wing across this one. All of you know, to the wing there is a big engine. Okay, so this is the small engine which looks like from external. There is a air continuously entering and the exhaust gas continuously leaving. This is called a mass flow rate of exhaust gas. This is the mass flow rate of air. Now if you see what is internal, if you see the internally, there is a compressor which will take the air coming in and compresses it to high pressure and temperature. This entire air now enters into a combustion chamber where I'll introduce some fuel which will get burned and you will get a high temperature, high pressure gases. Because of high pressure and temperature, I can run a turbine. Okay. Now to run the compressor, I need some work which I'll connect it to this one. And afterwards still there are exhaust gases which are sent through a converging diverging nozzle. So because of which there is a high velocity jet coming. All of you know Newton's third law. For every action there is equal and opposite action. Whenever the hot exhaust gases leaves this one, they'll try to push the entire aeroplane forward. Why? They're trying to push the engine. The engine is rigidly fixed to the wing. Wing is rigidly fixed to the aeroplane. That's how aeroplane will move forward. Now here you see this one, the air is again and again taken and exhaust gases are thrown out. It looks like it is a control volume. Strictly speaking, if I take the entire ambient into my consideration, am sorry the ambient air into consideration, then this is working as a dumping system. Strictly speaking, this is practically a open, but theoretically it is a closed, because the air is becoming, or a local atmosphere is becoming a part of my cycle. Means the entire ambient air is becoming one control volume which is closing my cycle. I am again and again taking air from the same atmosphere. I am throwing the exhaust gases to that one. This particular atmosphere is such a beautiful cooler. It will take any amount of high temperature exhaust gas, but gives me low temperature fresh oxygen, almost like, because it is infinitely capable. So that's how these are called as sinks in a thermodynamics. So it is automatically becoming a part of a cycle. When I take the local ambient air into consideration, this is also a control mass. Why? The same air coming from same where and going into same where. That's how these are called explicitly open cycle, but can be treated as a closed cycle. And the people will try to design and analyze by taking ambient air as one of the cooler. There is a heat loss there, heat gain is there. So that's how you can develop many control volumes, many control processes and various kinds of cycles. Okay, so go back to the, now because of this one, no, I need to learn more. So I need to analyze a cycle using a first law. Why? Just now I showed you. How can I get a cycle? There has to be so many parts. Without so many parts, there can't be a cycle. Should I have a first law only possible to have the entire cycle? What does it mean? Individual equipment, individual part of the cycle cannot be designed, cannot be anticipated, or I can't do anything unless all are put together. I can't do any kind of calculation, which looks like it is not a good scientific engineering at all. That's how the first law, which is naturally stated for a cycle, can be using a good algebra, because unless I have an individual equipment, I cannot construct a cycle. As an innovator, I may think cycle in my mind. When I want to develop a product, a pump should be manufactured by somebody, condenser should be manufactured by somebody, steam engine may be manufactured, steam turbine may be manufactured. So that's how a cycle designer will have all the cycles, but individual equipment should also be designed. That's how I should know how to apply this first law to individual equipment also. That individual equipment could be either control mass or a control volume. Very rarely individual equipment will be control mass. Still, for the sake of algebra, we will use first control mass. Again, whiteboard please. So this is a pure algebraic operation. Let me say I have a control mass. Okay. Nothing enters, nothing leaves this particular thing. And initially, this is, I take two parameters. It could be pressure volume, volume temperature, pressure temperature, any combination. So that's why need not be pressure, need not be temperature, or any two combination. You can call XY also. So initially, this particular one is having one state. Okay. So let us say this is the state A. So from A, I have done a process via path 1 and reached B. Okay. Now, what I want to know, I want to develop a machine which will work continuously forever. Now you see this one, A to B, one time I got some work, afterwards I will not get anything. I am not interested. The life will go on, go on, go on. Every day I have to breathe in. Every day kya hai? Every 72 times, almost 72 times per minute, I have to inhale, exhale. 70 times per minute, heart has to pump in, pump out, pump in, lub, dub, lub, dub. Everything has to happen continuously. It's not like one happening. That's how I need to do. Again, go back B to A via path 2. So let us say between A and B, I'm doing a simple algebraic thing. Okay, can you change the color of the pen, please? Yeah, color. Thank you. So now what I'm doing, you know, I have gone A to B via 1, but I'm thinking of two different possibilities to come back. Why? I don't know. I'm just doing a algebra. Now you see, I have created explicitly two different cycles, but extreme positions are same A and B, isn't it? So again and again I go to B, come back to A, but the paths are different. So you see, the first cycle which I am thinking is, I am writing the path A via 1 to B via 2 back to A. This is the cycle. And the next, let's say first cycle, let us say. The second cycle, what I am doing, A 1 B, forward is same. It is very important. Sometimes, you know, you have to do algebra without immediate returns. After doing algebra, the amount of returns you get is unreasonably valuable. Very important. Every knowledge becomes an information when you apply a good amount of algebra. Otherwise, you learn a lot. You have your computer with a lot of data. Don't organize them. Don't process them. Don't do anything. All this is a chunk of data. When you do some kind of increasing order, decreasing order, multiplying with something, subtracting something, then you will get a beautiful information. Algebra is such a powerful thing. I'm doing the same kind of powerful thing. This is the one, cycle 2. Now I can apply the first law to both the cycles, isn't it? So I'm developing cyclic integral of delta Q on a cycle A1B2A is equal to cyclic integral of work transfer on the same cycle A1B to A. Similarly, I am applying the same to the cycle 2 also. First cycle, second cycle. Cyclic integral of delta Q and A, sorry, okay, I'll write it here. A1 B3A, okay, which is identically equal to the cyclic integral of delta W. The path is slightly different, A1B 3A, okay, both are the cycle. So why I am comparing these two cycles? These two cycles are occurring between two same extremes of A and B. That's why I think that they should be compared more. I have to do more algebra on this. What is the more algebra I can do on this? You see this particular one, though it is a cycle, but at least it is constructed out of two processes, A1B, B2A, isn't it? So that's how I just want to detail it, the truth. Now, though it is a cyclic integral, this is delta Q via 1 from A to B, isn't it? Plus delta Q B to A via 2, isn't it? This entire thing should be equal to A1B plus delta W B to A. Okay, so this is the one detailing, because nobody on this globe can construct a cycle without knowing the individual equipment. The moment I have individual equipment, I have to change the state, change the state, change the state. And all connected together, last state is equal to first state, and hence I have a cycle. That is the truth. There is nobody can do anything different from this. So there has to be a morning before evening, and after the evening there has to be night, after the night there has to be dawn, dawn, morning, evening. There cannot be anything individually. You cannot have suddenly I came from morning and suddenly there is a morning. There is nothing between two mornings. Can you have today morning and tomorrow morning? In between there is nothing, and morning has come like a cycle without anything. No, the morning to dawn to morning, morning to afternoon, afternoon to evening, evening to night, night to dawn, dawn to morning. Everything has to happen. Then I got the morning. That's how individual processes are essential for anything. Now you see I'm doing the same thing, A1B delta Q plus B2 B3 A delta Q, because in this cycle reverse is different, backward process is different. The similarly A1B delta W, okay, plus B3 A delta W. So because both are occurring between the two extremes, you see you need to justify why you are doing algebra. Why these are compared? Because these are two different cycles constructed, but extreme values of A pressure or extreme values of temperatures, one thing is same, either AB or 1, 2, whatever I want it to. Let me take this particular one, okay. So we write in the next one for the sake of clarity quickly. So according to the cycle 1, what did I do? The cyclic integral of A1B delta Q plus cyclic integral of B2A delta Q is identically equal to the cyclic integral of A1B delta W plus integral of B2A delta W. This is one cycle. Similarly, I am comparing with the cycle 2. Both are occurring between something to compare. The cycle 2, what is it? A1B delta Q plus B2A delta Q, which is identically equal to this is 3, second cycle, okay? A1B delta Q delta W plus A3B delta W. So because I am comparing, I wanted to take the difference of these two. Okay. So sometimes it is difficult to justify why you are doing an algebraic operation till you get the final result. Okay. So that's how the research in algebra is very funny. You do some combinations, some permutations, etc. And the algebra which gives your final objective is tabulated, and remaining operations are thrown outside. Nobody can say, okay, I have done so many stupid operations. Finally, I got the correct thing because of this one. Nobody will declare that one. And so minus, 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 minus. So because this process is same, I can cancel these two. I can cancel these two. Now, what is the funniest thing happening? 2B A delta Q minus the B3A delta Q is identically equal to the B2A delta W minus B3A delta W. Now you see this particular one. 2, 3 were never in a part of a cycle. But I have constructed a new cycle out of the subtraction of this one, cycle 3, which is something like a to B 3A kind of thing. So now I am doing some more algebra. I want to compare the same path. So from along the 2, what all I did? B to A delta Q minus, I did this also, isn't it? So minus the B to A delta W. And what all I did along the 3, you see this one, the minus delta Q will go and become plus B3A delta Q minus the B3A delta W. So both are going along the same path, both are in integrals. So I can do this one along to B to A delta Q minus delta W. okay, is identically equal to along 3 B3A delta Q minus delta W. Now you see this one. So whenever I am going to the process, for each small infinitesimal process, what is the delta Q? What is the delta W? I am taking the subtraction of this. That subtraction I am integrating from B to A along a path 2. The same subtraction I am doing from B to A along a path 3. And very funny, this difference, whether I go along a path A or a path 2 or a path 3, doesn't matter. Very funny. And according to our definition of properties, any new variable, whether I don't know whether it is a property or not, if its a change is independent of path, that should be a property. Now it looks like for a quasi-static process which is done very slow, at each small changes, state of change, if I know how to compute how much heat transfer, how much work transfer, and their difference is taken at every stage and integrate along the path till end, that will be independent of path. Very interesting. Means the delta Q depends on a path, delta W depends on a path, but the difference doesn't depend on a path. It only the state property. Okay. Now, because you see this one, I didn't say what is 2, whether it's a constant process, constant volume process. I didn't say anything 2. 2 is any arbitrary process. The 3 is also some other arbitrary process. Means this particular definition is independent of what kind of path I am following. Whenever you have a definition which is independent of a path which is valid for any arbitrary path, no, if you recall integral mathematics or a differential mathematics or a basic mathematics, such a things can be written as integral b yr2 to a delta of q minus w, because for any process delta q minus delta w is same. I'm not giving any prescription. So I can say delta of Q minus W as well is identically equal to the B3A delta into Q minus W, which means that this should be something independent of path. Whatever may be the path, this should be same. Means I can write this as EA minus EB. So the difference, for calculating the integral value of their difference, I don't have to care about what is the process which I have to know what is the initial state, what is the final state. The way to know the difference in pressure, I need to know what is the pressure initially, what is the temperature pressure finally. To know the difference in temperature, I need to know what is the temperature before, what is the temperature after. I don't have to care how this temperature happened. Is it by compression? Is it by heating? Is it by expansion? Whatever it may be, I don't care. The change in temperature is independent of what is the path followed. This is also another new thing. And this has the units of joules. And the Q has the units of joules, W has the units of the joules, and hence their difference should be units of the joules. So see, the first time the whole world know very informally talking about energy, energy, energy. No commitment, no classical way of definition, no scientific way of treating. Just arbitrarily use the word colloquially, a word called energy, and misuse the energy. The moment you understand anything perfectly, I told you again and again, I am bringing the Lord Kelvin statement. If you precisely define, then you can measure. If you measure, means you know about that one. If you know about that one, you can conserve them properly. Without knowing anything, if you start using, you don't know. You are wasting everything. That's what happened in the entire society. The millions and millions of steam engines were developed. They were burning tons and tons of a coal, producing tons and tons of steam. None of them were aware of that. If I have a 1 kg of coal, how much work I am supposed to get? Why? They did not understand scientifically. And they never gave a number to that one before. If you don't give a number, you will misuse. Your understanding will be meager. So go back to this particular wonderful application of this particular energy term. Now, because it is a process, you believe me, this process could be by a control mass or a control volume. isn't it? The process can be done by either control mass or a control volume, isn't it? There is no rule that a process should be only control mass. Cycle will be on an average treated as a control mass because it's a cycle. Otherwise you can't define a cycle at all. The concept of cycle is really it may or may not be a control mass. The moment you are representing as a cyclic process, it has to be control volume. Mass is constant within the boundary. No mass crosses the boundary of a cycle. Otherwise, there is no concept of cycle definition at all. And you will go into a confusion how much I am taking, how much I am paying. Then you will never come to a conclusion of whether you are doing a good job or a bad job or a mediocre job. Very important. Whenever you are a cycle has to be treated as some fixed amount of mass. That mass is flowing with some rate because to complete a cycle it will take some time. So much mass is dealt in 1 minute. So mass by minute will give you some mass flow rate. Very important. I will not give a definition very generally without a vision. You need to have a vision that the moment it is a process, it could be a control mass or a control volume. Now the question is whether it is a control mass or a control volume, the energy which I am talking about should be same or will it be different? Or how many possible energy colors I can see is the one. Go back to that. So the formal thinking leads to a most powerful way of living. Okay, this I discussed. Sorry. Now, let me state this one. This is the one. For a process, del Q minus del W is independent of path. So according to the definition of the corollary of a property, any variable which is independent of a path during a change of state is called a property. A change in variable is independent of a path, then, so that's how I define this particular one. You see, if I want a delta Q minus delta W, unless I know the path, I cannot integrate. I don't know what is the net change. But if I want the difference of them individually, then I don't have to know the path at all. That is the greatness of doing such a elaborate algebra. This variable we are saying the E. And E is having a units of heat or a work because the difference of apples should be apples only. So the heat is a units of joules, work is also in the joules. That's how all are having well established units of energy, and this is the one which is energy. Now you see, if I say first law is a conservation of energy, we are fooling ourselves. The energy is a point function. Whether you do or not do, whether you know what is the path you follow or not, change in E can be easily calculated. If you are making a cycle, change in E is 0. The first law of thermodynamics is much more practical and broader than the conservation of energy. Why? Unlike a simple conservation of energy which is taught in a school under a science, this particular first law is talking about the conservation of energy while doing some great contribution to the society or a universe at a large. This first law will not talk about the energy not just by throwing a ball up and down. That is not the criteria. From the resource, which is a surrounding, and to the next surrounding, I'll give you some amount of work. Or you give me some amount of work, I'll cool the environment, like a refrigerator or a air conditioner. Very important. The first law of thermodynamics is much more bigger than the conservation of energy. No doubt, it is constructed on a foundation called conservation of energy. Without that, it is impossible. Okay. Let us think this. The first law for a control mass during process, if I want to write it, this is the one. For every small change now, delta Q minus delta W is dE. So delta Q depends upon the path, delta W also depends on path, but their difference will only depend upon the initial and final state, whether it is a very incremental or a very large. It is a infinitesimally small change or a finite change. This is the truth. That's how you see. When I integrate it, both delta Q, delta W are path functions. I need to know what is the path 1 to 2. But the difference doesn't require the path to be known at all. That's how you see there is a way of representing the truth. Whenever I want to know change in energy, I can write E2 minus E1. But whenever I want to know what is the integral of Q from 1 to 2, you cannot write Q2 minus Q1. That is stupid. Because you need to know the entire path 1 to 2. Now this 1 to 2 is asking for you how did you go from 1 to 2. Whereas E2 minus E1 is khatam, baat khatam. It's over, done. I don't have to know how did I get from 2 to 1 to 2. E2 minus E1, that's all. I need to know what is 2, what is 1. And similarly, to know the total integral of work transfer, I need to know path 1 to 2. Both are following some kind of path, their difference. So the paths could be anything. I can have a path where the Q1 to 2 could be 0. Then also energy will change. I can have a path where W12 is 0, then also energy can change. Means energy change can occur only by heat transfer, only by work transfer, or both heat transfer and work transfer. Anything is possible is the moral of this particular understanding. The change in energy of a system during a change of state is numerically equal to algebraic sum of heat transfer during the entire process and the work transfer during the entire process. There is an algebraic sum and this minus has to be appropriately respected. Okay, so the remarks are very important to see this one. We have a pressure, we have a temperature, we have a volume. But whenever I was thinking about a property like a pressure, volume, temperature, I don't have any kind of confusion at all here. Is I know there is a zero absolute pressure. So I can say pressure without any reference at all. And I know there is a zero volume. Okay, I know there is an absolute zero temperature. Now the question is, this first law is only defining the change in energy. Means unless I know 1, I cannot get 2. Unless I know 2, I can't get 3. So the first law is only talking about the change in energy. Now the question is, what is that zero energy state? Do I know? Do I have to know? Is an issue which has to be resolved very properly, very important. Here we are only knowing the change in property of energy. That's how no pressure, volume, temperature are called fundamental properties. Why? Their zero state is obvious, unquestionable. There is an absolute zero. All other properties which satisfy these corollaries, no, they're called derived properties. Why? Their zero state is very confusing. The people have a different references, etc. That's why no, energy has to be expressed with respect to some arbitrary reference. I need to know what is this one? Is it a 0 degree Celsius? Or all of you know from school, there is like a NTP, normal temperature and pressure. Some people say STP, standard temperature and pressure. Should I say the energy is 0 at STP? Should I say energy is 0 at 0 degree Celsius? Where should I say the energy is 0? Should I say energy is 0 at absolute 0 pressure and temperature? But I could never reach that one. Without reaching this one, how do I calculate what is that energy? If I don't calculate, then I cannot get a number. So the reference state is something very properties. The Q and W must be measured in same units, very important. Because long amount of confusion happen, all of you know Joule constant, etc. Just because the people gave us some units for Q, some units for W. Very important in an engineering. Whenever I write an equation, the units of left side should be exactly equal to units of right side. Otherwise, you cannot equate. Can I say 10 kilopascals is equal to 5 Kelvin? How ridiculous. There should be pre-multipliers. Otherwise, I can say the temperature is equal to PV by MR for an ideal gas. Why? The pressure, volume, mass and the gas constant together will have the same units of temperature. If you take such a fundamental units culture, which is a civilized engineering. Okay. So further remarks before I close, and next class we will try to sum up with the second law, maybe little quick, but we'll try to sum up. The energy of a system at any state A is the EA plus I need to know some reference because the first law gives me A to B only. Suppose if I am at state A, I don't know how did I reach state A, I don't know. Then I need to know I have reached A from some reference state. So you need to define that E reference. Okay. So initially the people assumed that, let us assume for every substance there is a triple point. So for a given substance, the people thought that at a triple point energy is 0. If you go below triple point, that is a negative energy. If you go above the triple point, positive energy. Same like a temperature, no? The people said ice point is 0 degrees Celsius. If you are producing a temperature below ice point, minus ledo, what is there? And if you are above the plus ledo, then the people got, how long I can go down, minus, minus, minus. Can I go to minus infinity? The way you can go to plus infinity. Somebody said, no, no, no. It is ridiculous to think about minus infinity. There is a finite amount of minus quantity. The same way, can I say energy also cannot go to minus infinity? Then the people started modifying. Maybe when you do higher courses, you will talk about how to give a reference state, okay, depending on the application. One popular definition, I am giving the most popular for a fundamental thermodynamics, but this definition may not be universal because biochemistry people will take some other reference. The combustion people will take some other reference for energy state, and the ordinary mechanical power generation will use something else. That's why I am giving a popular definition only. The stagnant liquid, it's not moving, it is contained. A stagnant liquid at a triple point at sea level will have a 0 energy. Means why I am saying sea level, if it is at sea level, potential energy is 0. Why I am saying a stagnant liquid not flowing? Because anything which is flowing will have a velocity. By the virtue of the velocity of from school, is a kinetic energy. And this energy could be kinetic energy, potential energy, or many more energies which you haven't learned so far. Maybe you know, but you never felt scientifically so far, at least. That is, I am damn sure. So energy is an extensive property. What does it mean? Suppose if I have these two, can you show me? These are almost the same pens. This has some energy, this has some energy. Let's say both have the equal energy, but when I join these two, okay, both will have the same temperature. Individually, this has the same temperature, this has the same temperature, there is some pressure, some volume. When I add together, the combined system will have the same pressure and temperature, but the volume will be double. Similarly, the energy of these two will be double. That's how the energy is not an intensive property like a pressure and temperature. It is an extensive, more volume, more mass, with the same pressure, temperature, same kind of thing, you will have that. That is also very important. It is an extensive property. The energy of a system unit per unit mass can be called as a specific energy. This specific energy can be called as a intensive property because you are taking per unit mass, and specific energy is an intensive property. Every extensive property can be converted into intensive property, but intensive property can never be converted into extensive property. This is a one-way definition. Very important. That's how people have to be very, very careful about dealing with the intensive properties in measurement. Okay. So there are various members. I'll talk about some of the new members before I conclude. The forms of energy, all of you know very well, and I ask teachers to elaborate more and more because this is a routine thing. All forms of energy fall under two categories. This is the one. I am giving only that particular knowledge which is not explicitly written in the textbooks or a conventional textbooks, not that I created. Advanced learning, research papers will talk about this one. Very important to know that the highest level of energy classification is according to this. After that you can further classify. What is that the highest level of classifying range? Something which you can feel by your thing. Suppose if there is something moving with a high velocity like a wind, I can say there is a wind velocity, this must be having some energy. But if I have this particular pen as it is, can I say does it have an energy or not? Why? I am not able to feel this particular one. Let us say when I touch this one also, I don't feel it's a cold or a hot. This is same body temperature. So I'm not able to feel with my senses at all. But even then, there is some energy which I can't feel, but there is an energy inside. Okay, so you need to have a global way of members, and it's very important. If you don't do no, there is no innovation. Okay, so you imagine the man was interacting with the nature. How many millions of times he came across the coal, but it never looked like it has an energy. Why? That fellow is not moving. So the water, the moment he saw the water flowing, there is a possibility there is an energy. The moment he saw wind blowing, he thought there is an energy. The moment he saw bullock moving, it has an energy. The moment he saw horse moving, he saw the energy. But lumps and lumps, tons and tons of coal lying him, till the beginning of 18th century, I suppose, or 17th century, nobody thought that this has an energy. Why? My macroscopic senses could not feel that one. So that's how very important to understand the energy availability. Okay, is microscopic, macroscopic. Same thing, radioactivity, nuclear fuel. By seeing a nuclear fuel, can you feel this has abundant energy? Unless it translate a radiation, that radiation will affect my eyes or my skin macroscopically, then only. Should I wait till I get hurt that this has an energy? Very important. Only the great Einstein can think that there is some energy so microscopically. Somebody else thought microscopically. That's how very important to know that the energy can be felt available in a macroscopic form. What is the meaning of macroscopic form? Macroscopically, this is at a height something. So because it is at a height, there is an energy. The macroscopically, it is flying. I could see the velocity. Those are macroscopic, like a wind power, hydropower, explicitly available. That's how I started using them easily. I saw the macroscopically horses running, elephants pulling thing. The people observed, if you don't tame an elephant, and if you see a wild elephant in forest, just for the sake of exercises, it will spoil the entire forest. It will go and hit a hill or so because it has to do some exercises. It has to dissipate energy. So then when I saw, oh, this has an energy, I can use it. Those are macroscopic in nature. But microscopic things are very powerful, abundant, takes a lot of time to grasp them. Okay, the potential energy. Afterwards, you can have a microscopic potential energy, macroscopic potential energy. Or you can have a microscopic kinetic energy or a macroscopic kinetic energy. You will have the combinations and permutations. In fact, no, the potential energy is stored energy, and the energy by virtue of the state or a position. You know, if you have too many protons in the nucleus, they'll have an extra energy. That is the by virtue of position of a state. If the number of neutrons inside the nucleus is very small, they don't have that extra energy. What is this? By the virtue of the position, state, configuration, it should be macroscopic or a microscopic. And I take an arch and stretch it. The moment I stretch it, it contains a lot of energy. And if it is a stationary, no energy at all. There is a macro potential or a micro potential which I could not feel at all for a long time, that inside the nucleus, if there are some protons and neutrons together, they have a abundant energy. And that is microscopic, very difficult to feel. That's how no, a scientific feel is very, very essential. Similarly, the macro potential energy is gravitational energy, strain energy, etc. And what is the micro potential energy? Is the chemical energy or a nuclear energy. How come? After all, everything is a carbon, hydrogen and the oxygen. Just by eating CO2, drinking CO2, why don't I get energy? Same thing, and you take CO2 and H2O water, can I get energy? No. And the same CO2 and H2O taken by a tree, and if it becomes apple, I eat apple, I'll get energy. What is this? The carbon, hydrogen, oxygen atoms are nicely constructed in a configuration, and they'll get a micro potential energy, which is called a calorific value. Mera book mein jati hai, etc. I get a lot of energy. Very important to realize. Okay. So the kinetic energy is due to the motion, the motive energy, the motion of the waves, electrons, atoms, molecules. It could be macro or it could be micro. The next class perhaps on a Saturday. I'm trying to get a date tomorrow if possible. Otherwise, on a Friday, I'll try to close. Very, very important. Again, I am saying I'm trying to tell you some topics which are not straightforward in a book and how to understand them. Otherwise, no, the topics are available in the books. What I am teaching is some more, what I say, pragmatic way of understanding. This is what is called. You need to get a feel of whatever you listen to. That is called a pragmatic way of understanding. And don't think that I haven't covered all the topics. That is not fair. Teachers should know there is other way of teaching. Students should also know that there is other way of understanding. I'll close the topic, but don't think that I haven't covered all the topic. But you go to my website, all the 42 lectures are available on my website. And you go through any doubt, you just write a mail to me. I'll explain what do I mean by these sentences on my lecture slides. But I have all the 42 lectures already available on my website. Engineering thermodynamics is the thing. Go to my website, download all. You can modify them because they are just PPT files. Okay. Any questions? Okay. Thank you.